This is assignment 6. In assignment 6, we're asked to create two arrays with a length of 20,000 and insert the same amount of random numbers into each index and sort the first array using a bubble sort and sort the second array using a heap sort. Both lengths of time to perform each sort should then be printed to the user. So in our header file, here we list all our functions we'll be using in the program. We have the bubble sort function, the fixed down function, and the heap sort function. So now we can write the implementations for each function. First, we begin with our bubble sort function, and the bubble sort code sorts in ascending order. So here we declare some variables for our loops and a temporary variable to store different indexes. So we need to loop through each number in the array and check whether or not the number in the index is greater or less than the number in the next index. So in the loop, in order to compare numbers, we need to form a comparison. This is done by comparing index j in the array to the next index, which is done by adding 1 to j. This is the number in the next index. We want to swap if the first is larger than the second, and each pass through the data sorts one more item into place. So each time storing a new number into the temporary variable, and this is repeated for each number in the array until it's completed and sorted. And next we can write the fixed down function, which is used to implement a heap-based priority queue. This is a top-down heapify which swaps the newly modified node with its larger child. If the new node is still smaller than one or both of its new children, it repeats the previous step. Otherwise, it's done. So to do this, we can use if statements and check if the left child is larger than the root. And if so, we make the left the largest. If the right child is larger than the largest so far, then the right is the largest. And if the largest is not the root, we want to store it to the temporary variable to use it to compare. Then we can recursively heapify the affected subtree. So our last function is the heap sort function, which works by transferring items to the heap. Heap is a balanced binary tree where all parent nodes have greater values than both children. So the root of the heap is transferred to an array, and the heap is then heapified. So the process is repeated until the sort is complete. To do this, we need a for loop to build our heap or arrange the array, and then we can call our fixed down function. Then in another for loop, one by one, we can extract an element from the heap and move the current root to the end, and then call the max heapify on the reduced heap. And then finally we can write our main function. So in our main file, we need to generate random numbers from 1 to 20,000 and initialize them in both arrays at the same index. So here we have two arrays using a for loop to create a random number 20,000 times for each array using the rand function. By modding it by 20,000 and adding 1, this generates a random number from 1 to 20,000. And then we can initialize the random numbers to each array at the same index. Then we can start the clock, call our bubble sort function to begin sorting. Then we end the clock and then calculate the time it took to perform and then print it out. And that exact same logic is then applied to the heap sort. So now we can run the program. And the time to perform the sort for the bubble sort and the heap sort are printed. And as you can see, the bubble sort takes much longer to sort, while the heap sort takes less than 1 second. So now we can add a breakpoint into array 2 and see the contents in array 2 after it's been sorted. And then we can add another breakpoint into array 1 where the bubble sort is being done. And then once we run it, we'll be able to see the contents in array 1. You can see that it's being sorted as well, and it's the same as the heap sort. And that is assignment 6.